Hey everyone, good morning. I am Priyan Shekdwar and welcome back to my YouTube channel. Now we are going to solve today's Leetcode daily challenge, which is find elements in a contaminated binary tree. Okay, so let's see what is this question and how we can solve it. So in this question, you are given a binary tree with the following rules. With root value is equals to 0. Okay, so in our binary tree, the root value will always be 0. And for any tree node, if a tree dot value has a value x and its left node exists, then the value of the left node will be 2 into x plus 1. Okay, so let's say if the root node is 0, then its left node value will be 2 into 0 plus 1, which is 1, and its right node value will be 2 into 0 plus 2, which is 2. Okay. If its right node exists, then its value will be 2 into x plus 2, and if its left node exists, then its value will be 2 into x plus 1. Okay. Now the binary tree is contaminated, which means all the tree node value has been changed to -1. Okay. So what we have been given is that this binary tree has been contaminated and all the values has been changed to 1. Okay. You need to implement the find elements class, which is find elements node root initializes the object with a contaminated binary tree and recovers it. So what you need to do is you need to recover this tree with the help of this find elements class. You need to recover this tree something like this. Right? Let's say if we have some further nodes, so what will be their value? 1 into 2 plus 1, 3. 1 into 2 plus 2, 4. Similarly, if we have more values and so on, then let's say they would have become -1, and then we need to recover those nodes as well. Okay. And we need to, okay, but how we can recover those values? We already know that the root value is going to be 0 always, right? So we can start with the root value and do a simple in-order traversal in the tree and recover all our values, right? So in this way, we will be able to recover our binary tree with a simple in-order traversal. Okay. And bool find target returns true if the target value exists in the recovered binary tree. Okay. And we need to implement one more function, which is target, which will return true if value exists in our tree or false if value doesn't exist in our tree. Okay. So what we can do? Every time either we can traverse on this complete tree for checking whether this target value exists in this tree or not. Or what we can do? See, after recovering the tree, there are no changes in the values of the tree. So what we can do? Instead of traversing complete tree every time when target function is called, when this function is called for the target value, we can store all these values in some data structure. Let's say set or map, and then do a lookup in this data structure that whether this target value exists in this data structure or not. This will save our time for iterating this complete tree every time for checking this target value. Okay. So yeah, we need to implement this find target, find function and this find elements class. Okay, so let's see with these test cases. So you have been given with this tree of -1, -1. You need to recover it. So what it will become? 0 and 2. 0 with the root node and 2 into 0 plus 2, which will become 2. And then we need to do find 1. Yes, no, 1 doesn't exist. So what we have done here is, so you can store the values in the set either while traversing this, either while recovering this tree, or either in a different traversal after recovering this tree. But we can store the values while recovering the tree. It will save our one more iteration. So while recovering the tree, we have created this set 0, 2. And then we need to find whether 1 exists in this set. No, 1 doesn't exist. So we will return false. Now we need to see whether 2 exists in this tree. So we will do a lookup in this set whether 2 exists. Yes, 2 exists. So we will return true. Okay, similarly for other examples, you have been given with this -1 tree, contaminated tree. So what will it will become 0 with the root value, then 1, then 2, then 3, and then 4, right? Okay, now what you need to do, you need to store these values while recovering the tree. So this will, our set will become 0, 1, 2, 3, and 4. And we need to find 1, whether 1 exists. Yes, so we will return true. Whether 3 exists. Yes, we will return true. Whether 5 exists. No, so we will return false. Similarly for this example, we will recover this tree 0, 2, and then 2 into 2 plus 1, 5, 5 into 2 plus 1, 11. So what our set will become? 0, 2, 5, and 11. And then we need to check whether 2 exists. Yes, we will return 2. Whether 3 exists? No, we will return false. Whether 4 exists? No, we will return false. Whether 5 exists? Yes, we will return true. Right? So what we have to do is, first we have to recover our tree with a simple in-order traversal. And while recovering the tree, we will store all the values of the tree in our unordered set. And for the find function, we will simply do a lookup in our set, right? Okay, so let's try code this. So first what we need to do is, we need to create an unordered set of integer, let's say tree values, and then we will create a recover tree values function, which is a simple in-order traversal in which we will pass root, comma, current value, which is 0. Okay, so let's implement this function, recover tree values, tree node star root, comma, current value. Okay, and if root is equals to null, then what you need to do, you need to simply return, nothing to do with this. Then recover tree values on the left node, and what our current value become? Current value into 2 plus 1, right? And we will push our current node in our tree values dot insert current value, and then we will do the traversal for the right hand side, right node. Then our current value will become current value into 2 plus 2. Cool. And then for the find function, what we need to do? We need to simply do a lookup whether tree value dot contains target. If yes, then it will return true. If no, then it will return false. Okay, so let's try run this. Yeah, it's working fine. Let's try submitting it. Yeah, it's fine. So what will be the time and space complexities for this? So the time complexity for find elements will be big O of n, right? Because we are doing a traversal, and space complexity will also be big O of n, as we are using that set for storing all the values. And for the find function, the time complexity will be big O of 1, as we are just doing a lookup in our unordered set, and the space complexity will also be big O of 1. Okay, so yeah, this was all for this question. I hope you get it, but if you still have any doubts, then you can post in the comment section. I will surely try to answer them. Till then, bye guys, see you in the next video.